So my name is Nick Mehlig. I'm a stress engineer here at SDA, and I've been working here for 5 years now, a little over 5 years. And so I've done a lot with Femap, with NX Nastran, and along the way you learn lots of tips and tricks. And post-processing is really where you can start to save time and start to figure out better ways to visualize data, output data, and kind of just get a workflow that works best for you as well. So today we're going to be going over post-processing methods, as well as I'm going to do specific examples with enveloping for multiple output sets and performing calculations on separate output sets. And it'll kind of be in a demo mode as well, so you'll kind of see some of my workflow and how I personally like to move through Femap. I always think that's useful for the viewers. So let's jump in. So who are we? We are a team of 19 engineers, anywhere from having bachelor's degrees in aerospace engineering or mechanical, and some are in engineering science and mechanics. We have some engineers have their master's degrees, and we have an engineer that also has their PhD, their doctorate. And we all specialize in Femap using NX Nastran, and we primarily work in Femap every single day. All our projects will always be in Femap at least part of the day, if not all day, making either making FEMs or processing the data and using it for our analyses. Some of the recent projects that we've been working on in the space industry, we've worked on the composite crew module, the Orion heat shield, the crew module, the Roman telescope, NASA Goddard. We're working New Glenn with Blue Origin, and the Sierra Nevada Dream Chaser. For aircraft, the Piper M600 wing. We worked with Airbus, Commuter Craft, and Boom Supersonic for the XB1. We work with quite a few UAV companies as well, AI, Aerosonde and Shadow, VXP, Valancy Precision, and quite a few others as well. But we also take on other projects as well, such as Hagler dredges, Great Lakes dredges, and TLD is doing ground air support. So we're not quite limited just to aircraft and space. We do get some customers that also use our skills for structural analysis. So we are a Siemens value-added reseller. What that means is we sell CAE and CAD software, primarily with the Siemens suite, Femap, NX Nastran, Simcenter 3D, and a bunch of others, Fibersim, NX CAD, Solid Edge. We offer training, introduction to Femap and NX Nastran, advanced Femap with NX Nastran, and also Fibersim. And we have a training coming up. If you're interested, you can get in contact with us and get yourself a spot in the training. And we also offer support for Femap and Nastran and Fibersim. And we also do webinars semi-monthly. So I'm just going to go ahead and jump right into it. We're talking about post-processing today. So I figured it was worthwhile to talk about what exactly is post-processing. Well, let's start with what the finite element analysis steps start with. With step one, you typically start with modeling. You put in loads and boundary conditions, and you set up what kind of analysis you're going to be running. You can run static analysis, modal analysis, nonlinear. That all happens in step one, which is known as the pre-processing. Step two is actually solving the finite element model, solving all the equations, the stresses, and what output you're actually looking for. And that actually happens external to Femap. It happens in Nastran. They're two separate softwares. Step 3 is actually loading in the Nastran results, which is in the form of an OP2 file. You'll hear me reference that later on. So you load the results, and you're plotting the deformations, creating contours, exporting data, plotting, deflections. All that is done after the solution of the Nastran model, and that's known as the post-processing. It's essentially what is done to the Nastran data after you've imported it into Femap. So how exactly is the data imported into Femap? So usually after you run the analysis and it gets sent out to Nastran, it gets solved, Femap will automatically import the results. You'll see a loading bar, you'll see it cleaning up the output sets, and you'll be able to see them in your model tree. But just because it happens automatically doesn't mean that there aren't other options or settings that you can set to change how the data is actually displayed once it gets loaded. You have, as you can see on the right here, I have boxed out and attached to results. So there's two ways that you can actually import the data. It'll actually get saved into the ModFem, or you can just have the ModFem reference your OP2 files. When you have OP2 files that become very large, it's more beneficial to be having them attached to the results, because otherwise then everything gets saved to the database and your ModFem files will become very, very large. So as you can see here, this is a screenshot of how my settings are chosen. I always keep the attached to results on because lately my OP2 files have been on the order of like 2 or 3 gigabytes. So it saves me time because it doesn't take so long to load them in if I have this attached to results files on, and it also keeps my ModFems at a very low file size. Another option I have boxed out in red is this Nastran options for subtitles and appending the Femap title. This shows how, when you're looking at your Nastran output sets, you can change how it's naming them. The default is it'll just say case 1, case 2, case 3. What I had it set to here will actually use the same load case ID in the output set ID and the same load case title. That's when you have a lot of load cases and a lot of output, that becomes super useful to actually see, well, what was case 1? I got to go back and check, or you can just see it in the title from what you're post-processing within that output set that, oh, this is load case, whatever it's called. Okay, so I'm going to jump out of the PowerPoint and we're going to jump into Femap, where I have a model loaded up. And I'm just going to get some things set up here, and then we'll jump into kind of playing with some of these results. So I have a model here of a leading edge. It's a composites model. And what I'm going to do here is we have 3 load cases set up, and I'm going to run all 3 of those. This way we have more than one output set. So I'm going to go through and set up an analysis set right now. So I'm going to click New, and I'm going to choose a static analysis set, and this will be pressure. And we'll go through some of the options here. I think I'll keep all these the same. I'll turn on SR comps. This will give me composite failure index. It'll actually turn it into a strength ratio, which is very nice. We'll keep all these the same, and I'll request strain as well. And I'm going to set up a multi-set. Leading edge scan. And I'll use the front spar boundary condition. And that pretty much sets up 3 separate load cases in my pressure analysis. When I hit OK, we'll see it pop up here. And I'm going to go ahead and run this. And we'll wait for the results to come in. Well, as this is running, I'll go through and talk a bit about where we can actually access this data once it comes in. There's, like kind of anything in Femap, there's usually more than one place where you can access certain things, which I think brings a great opportunity for kind of creating your workflow a little bit more unique. So in the post-processing toolbox, once this data comes in, you'll be able to actually see and manipulate a lot of the data within the toolbox itself. You can also be using the menus that are up here to also choose pretty much the same data in different windows. The toolbox was something that was added on that made it a lot easier to basically put all those post-processing tools and keeping all the data all in one area. So here we've met to the sparse matrix solver portion of the model. So we'll go ahead and let that solve. Maybe I'll drag in a OP2 while that's solving, just so we can kind of look at some stuff. So what I've done is dragged in an OP2 file just as a placeholder so we can kind of get an idea of what these menus look like. So in the model tree, we have this results section, and these are going to be our output sets. And they also make analysis studies to help organize, but this here, the case 1, is the output set. And what I'll do real quick is change my preferences before this other one loads in as a subtitle, and we'll see how that names those. These output vectors you can choose from the list. So within the post-processing toolbox, you can choose your different output vectors from here. Anything that comes out of Nastran is in here. We have the translations, we have constraint forces, glue forces, all the way to ply-by-ply strains and stresses. So if I put a max failure index and we put that on the contour, you'll see this come up, that this is my maximum failure index. We have what's called data conversions here between averaging, no averaging, max centroid only. This basically tells the contour how you want the results to be visualized in the contour. Averaging will use corner data at the nodes to average it in between the elements. It makes more of a smooth contour. But sometimes you don't want any averaging at all. And you can turn off continuous colors and it'll actually show you what looks like a criteria plot. But okay, so we have these results loading in. So if I turn off continuous colors, you see it gets a lot more pixely. The picture doesn't look quite as pretty, I guess is the word. But this I prefer to use the contour this way because in the scale on the right, you can see the exact color that you're in when you're comparing the two. And then if you do max centroid only, right, basically what that's going to do is plot the, on the contour, it's going to plot the, it's like the max from the element that is, if you have an element that's touching, excuse me, if you have a node that has 4 elements on it, at that node it's going to pick which element has the maximum. But most of the time this will stay on average, and it's not necessarily something that needs to get changed. What I'd like to show here though is within the post data menu, this looks totally different than what does from the post-processing toolbox, but it allows you to do the same things. It's just in a separate menu. It's funny that technically I use this to choose my output sets and to choose my deformations and my contours. I prefer to stick to this menu mainly because, well, when I learned Femap, this is how I was taught. So some of it comes down to being personal. So we have our 3 other output sets here, and you notice how this says Simcenter Nastran case 1, and these actually have the titles of the load case: front spar, skin pressure, constant. There's my skin pressure constant. The front spar talks about what constraint I used. So it's saying I used the front spar constraint. And the skin pressure is saying what analysis, skin pressure constant is the load case. So let's go ahead and do an enveloping example. There's a couple ways that we can do the envelope, and I'm going to do it through the the model output process menu first. And we're going to go through here. Now, what enveloping does is essentially I have multiple output sets, but I want to select data. Like I'm going to create an output set, which is an enveloped output set, which brings data from all of the output sets that I'm selecting and puts it into its own output set. So what I'm going to do in this menu, I'm going to choose my max value. I'm going to be on the envelope tab, and I want to go 1 or more selected outputs. And you have a few options that you can choose. We're going to envelope failure index. And what I'm going to do is envelope all selected vectors. In this case, since I'm only selecting 1, this really wouldn't make a difference. But I'm going to select all 3 of these. And then I'm going to select my failure index plot. Oh, let me reset that. So what I've just told this menu to do is go through all 3 of these output sets and pull the max value for failure index for each element and create me a new output set. And in that case, we'll get this new output set here. It says envelope all vectors. And now what we're going to have to do is go back to the post data and choose this enveloped max output set 6060. By default, when it makes this output set, it numbers it in the 24 million range. I think it just chooses to set it really high, just in case if you are adding to an existing output vector, it wouldn't want to overwrite any of the data. So essentially what we're plotting now is the maximum failure index at each element for all 3 of those load cases. And this is a useful plot to have because now you have all your critical margins for all your load cases on one single contour, instead of having to go through and look at each load case individually and determine what's failing. Not only is it good to make a picture like this for maybe a report, but it actually allows us to pull some information out of this. So typically what I would do for one of this workflow is I'd want to see what the max was. So what I'll do is go to the post-processing toolbox and turn on some max min labels. And it's really hard to see sometimes, so I'm going to go ahead and erase back. I just hit F6. This is what's called the F6 menu, because I want to erase the back. Now I can actually see where it is. We'll turn off some of these coordinate systems as well. So you can see we have a max down here of 0.406 failure index. So what I want to know is what load case is that for? So let me turn on the criteria plot. And let me go back to my envelope data and click the next output vector, which is envelope set info. What the set info is it's going to tell me what output set ID corresponds to this maximum failure index. And you'll see it's load case 2, which is this one. Well, it's technically output set 2. That could get confusing. But now if we actually look around, we know that actually output set 2 is critical for everything. Typically in some areas, if you had different load cases driving other areas, you would be having different numbered load cases pop up. It might be 1 over here, it might be 3 over here. In this case, 2 is the worst. There's another way that you can envelope. You can actually just right-click directly on a analysis study, and you can envelope the study right there, max or min value or max absolute value. When we went through and did the output process envelope, one of the things I wanted to mention is that I could actually do 1 or more output vectors at once. So I could choose as long as they wouldn't be max and min. If I was doing strength ratio, I'd want a min. I could also do max absolute value. But as long as you do envelope each vector independently, you could actually choose more than one output vector if you wanted. I could choose 6060 and 6066, and it would envelope all of those. So if we looked at our post data for this, you'd have laminate failure index and set info for that. You'd also have a min strength ratio. So let's go back to the PowerPoint real quick. And let me set this back up. So we talked a little bit about enveloping. There's one specific example I wanted to show that kind of shows the power that you can use within Femap of actually processing the data directly within Femap. A lot of times it's pretty customary to export data to the data table and then read it into Excel, and then you can kind of just do your math based on that. But you can actually do math directly to output vectors within Femap. And what we have here on the right is what's called the function reference. Anyone who's used Excel knows you can type in SQRT is square root, or ABS is absolute value. Femap actually has those functions, similar functions like that built in. And if you go into the Femap user manual, it actually has a function reference, and it kind of explains what they do and how can you use them. These functions work in calculating, or if you're making a data surface, you can use these functions. If you're making some kind of load function versus time, you can use these. So these become quite useful. And we'll be using some of these, XEL, XND. So we're going to go through a calculation example using these functions, and it's going to be between two vectors, two output vectors. All right, so let's jump back into the model real quick. So once again, we'll go to the model output, calculate. That's the second one on the list here. And while I have this open, I think I'll just describe some of these other functions that they have available here. From load is a useful one. You can actually create a load from an output. Typically, I've used this for if I'm making a breakout model and I need to bring loads from one global model to the small breakout model. I'll typically bring displacements. So from this one, you can actually bring loads. You can actually create load definitions from Nastran output through this command. And that one actually is very useful. I use that one quite a lot. So let's use the calculate. And we choose a output set. And essentially what you're choosing is not what output sets you want to use in this calculation, which seems counterintuitive. What you're choosing is the output set that is going to create the new output vector. So I'm going to do a calculation on two of my output sets. But in this dialog right here, I'm choosing in what output vector do I actually want to put it into. And then you get this dialog here. So what we're going to do is we're going to be working with elemental data. And what we're going to do is we'll do something simple. We're going to subtract failure index. We're going to make a plot of the difference of the failure index between two load case. Failure index difference. So what I'm going to do is I'm going to use the function vec, which is choosing my output vector. Then I have to choose what my output set ID is. So first we'll choose number 2. And we separate our inputs using colons. Here. Then we're going to put the output, or the output vector that we want, which is 6060. That is the laminate failure index. And we'll do another colon. And then there's this ID variable, which is default by I. The proper way to type in for all variables is an exclamation point I. That third input there is essentially saying my variable is talking about elemental data, and the exclamation point is saying cycle through all of the elements. If you had a specific element ID you wanted, you would put it in there. And let's subtract it from vec. Three, 60, 60, and same thing. Enter the elements to select. I'm going to pick, I'll just select all of them. And it's just going to go through and essentially look at the failure index for all the elements between those two output sets, and it's going to perform a calculation on them. So like I was saying before, typically you might just output all that data to the data table and then copy and paste it into Excel and run the calculation. But for something that's easy enough to calculate within Femap, it might be beneficial that you would use that to create a contour plot within Femap, and now you have a picture that you can put into a report or on some slides, or even just to have the data all in one place, and that kind of keeps it easy. It's still loading. So once it finishes loading, I'll show you what it looks like. But you would access it just how you would any other output set, whether in the post-processing toolbox or in the post data options dialog. We'll see if it loads here, if it takes too long. Yeah, I'm not sure it's going to load, but while it's loading, I'll talk to other examples you might use this for. You might want to know the difference between the plate top stress and the plate bottom stress of plate elements in your model. And actually this equation is showing exactly that. So 7026 is your plate stresses. So actually this one is 7026 is plate stresses, and it's creating a ratio between output set 11 and output set 15. Anything that you would find useful doing that can be done directly within Femap. So let's see if it loaded, and if not, we will call it. And I think it's still loading. So I think there we'll end it. We'll talk to my contact information here. Once again, my name is Nick. If you have any questions about what we've talked about today, or really any questions in general, feel free to reach out. If you have any questions about pricing, or to see a demo for any of the softwares that we had listed above, you can contact our Director of Sales, Keith Brennan, and his contact is down there. And I'm going to be downloading the questions, and I'll try and get back to everyone shortly. All right. Thanks. Bye, guys.